Hello, and welcome to today's episode of Control Intelligence. I'm Mike Bassador, Editor-in-Chief of Control Design, and your host for today's podcast. In this episode, I'm joined by Jay Hendricks, who is Product Marketing Manager of Connected Power at Sola HD Emerson. We'll be talking about power supplies and equipment troubleshooting. Many pieces of the control system require DC power in order to operate. This could include sensors, motors, solenoids, valves, PLCs, controllers, HMIs, remote I/O racks, industrial PCs, vision systems, and network gateways. However, after the DC power system is designed and devices are purchased and placed in the enclosure, they're often forgotten. Maybe they're given a token look every now and then to make sure the LEDs are blinking, but as long as the system is functioning, all is good. But what happens if there is a failure with the 24-volt power system? A power supply failure for a critical process controller or device can lead to an unplanned shutdown of critical plant equipment or processes. Without critical event visibility, plants don't have the necessary tools to troubleshoot issues before they become catastrophic. Fortunately, there are solutions to these problems. Now there are power supplies that can give you a window into their health. Jay Hendricks is Product Marketing Manager, Connected Power for Sola HD Emerson. He's responsible for product vision, strategy, and development for Sola HD connected products. He has more than 30 years of industry experience in product management, building controls, and technical integration. Hendricks holds a bachelor's degree in electrical engineering technology from Purdue University and a Master of Business Administration from DePaul University. Welcome, Jay.
Hey, it's great to be with you today, Mike. Thanks for having me.
Yeah, you bet. Great to have you here. So let's jump right into it. What specifically are the benefits to monitoring 24-volt DC power supplies?
Well, we get asked that question a lot, actually, Mike. People tend to buy their power supplies and put them in a cabinet, and they seem to last forever, and that's a good thing. But, connectivity actually provides you a window into your power supply's health. And that gives you the ability to monitor where you couldn't actually in the past. And through this connection, diagnostic information is communicated on the network to the control system. And this allows the operators to monitor and trend key information from the power supply, alerting them when critical events are occurring. And this enables you to catch the problems, hopefully before they occur, because once things happen and things go haywire, it's too late at that point. And some of the information we might actually trend or monitor could be like over temperature or over voltage or too high a load. So those are the things we want to try to monitor in advance where we couldn't in the past.
That's phenomenal. The new age of smart devices has really given us kind of a window into what's actually going on and enabling everyone to foresee what could be happening rather than waiting for a failure event and then scrambling to make a correction, correct?
Exactly, because we want to try to catch an issue before it actually happens.
Absolutely. So what about a power supply that has a DCOK contact? Isn't that good enough?
Well, that has its use, and that's been used for many years. And still used today, and it's still going to be used going forward. That DCOK contact, actually provides you an indication that the DC power output is still good. And that relay would open up if there's no DC power. And that's very useful in redundant applications or, in a safety shutdown sequence, for example. But once that opens up and the DC power is lost, it's too late at that point to do anything about it. You've already lost the DC power. So it's really an after-the-fact indication.
Right. So I know you touched on this already, but can you go into a little more detail about why it's important to monitor that 24-volt DC power supply? What kind of smart power supply, like what kind of information can it tell me?
Yeah, that's a good question. It's very important for those clients and customers and integrators where critical production process or batch production is absolutely important. And, if that production process were to be interrupted or shut down, that there would be catastrophic loss. Mm-hmm. And once you have that catastrophic loss, that whole batch is wasted. So that means the equipment is offline during that time. That means they might have to dispose of the wasted batch, which could cost lots of money, and it could actually cause, a safety issue. So What we want to try to do is enable the operators and service technicians to, catch a problem way in advance. For example, something that might be useful is to look for unbalanced loads. In batch production, they use redundant power supplies because it's really important that they keep it running. But they might want to look at, unbalanced loads, or, has additional loads been added to my power supplies over time? Because, things happen in a plant and things are added. So, they never know when that may happen. And, after the fact is too late. So a connected power supply can provide you, real-time information, such as the input and output voltage, and currents, power supply temperature, power supply alarms and events, and even useful life information. And some manufacturers even make available temperature sensor built into their devices that enable to show the temperature inside of the cabinet. So this is all useful information that can be provided to the technicians and operators.
Wow, yeah, that is kind of amazing. There's a lot of those things that most people, even 10 years ago, didn't even realize that was information that could be useful, and now it's readily available. You did mention the ability for some of these smart power supplies to be able to talk about remaining useful life. Can you talk a little bit about the life of a power supply? What factors would impact, say, the life of a power supply or the remaining life?
Yeah, so really the life of a power supply is going to be affected by how hard it's been used. So how hard it's been loaded over time, and its environmental temperature, the temperature it's been operating in. So we might call that stress, how hard the power supply has been stressed. And you never know, depending on the situation and the client, how that, or the customer, that actually might change based on its usage, right, within that environment. Mm-hmm. So the things that really drive a power supply's life is stress, which is load and temperature.
Right. So in terms of that overall useful life, how long, I know at the beginning you mentioned that people think like you put it in and it lasts forever, but how long should a typical power supply last? Yeah,
a power supply should last, at least 10 years. But again, depending on how hard it's used and stressed, throughout its life, that time frame is going to vary. It could be less or it could be more. But the nice thing about that is manufacturers are providing ways of knowing or giving you a better indication of what is the life left in a power supply. And that could be done by providing you the runtime hours. And you can monitor the runtime hours inside of from the power supply and compare that to the specification data. So hey, I've been running at 50,000 hours or 100,000 hours. Well, my power supply is rated at 200,000 hours at a certain temperature. This means I have so many hours left. So I got to start thinking about replacing this power supply. But even better than hours is some manufacturers are building in useful life calculations. So this would be a calculation based on stress again. We talked about stress earlier, but stress in the power supply. So how hard it's been loaded and what's the environmental temperature that it's been operating in. And this calculation, would give you a countdown indication. So, and that may be similar to like the oil change gauge in your vehicle or in your car. So you change your oil every 5,000 miles, right? And it gives you a countdown, starting at 5,000 miles down, so 100% down to 0%. So that this stress level indication or useful life indication inside of the power supply may be similar to like that oil change gauge in your car, which would be very useful information, right?
Right. Absolutely. Yeah, absolutely. So the ability for the power supply to tell us things, great innovation. Can you tell us a little bit about the network protocols? So for smart power supplies, what protocols are necessary or what's available?
Right. The good thing about this is there's a lot of options here. It really depends on specifications of the project and what the needs are of the customer. How are they communicating today and what protocols are they using on the project? But from an Ethernet standpoint, there's high speed. There's some good options here: Ethernet IP, EtherCAT, Profinet, and even Modbus over TCP would be great options to provide communication from your power supply onto a network. In the process world, another heavily used protocol is HART, Highway Addressable Remote Transducer Protocol, and that's used like in process control situations, and that may be a great option because you could leverage something that you're already using. And some suppliers have even adopted or used IO-Link, which is a short distance point-to-point protocol. So that may be an option for your situation.
Sure. Sounds like you have pretty much all the bases covered with those protocols.
Certainly.
All right. Yeah. Well, thanks. Great conversation. Very insightful. And to be honest with you, I had no idea power supplies were quite as smart as they are these days. They've really moved into the Internet of Things world, just like all the other devices.
Exactly. And I think our challenge is to get engineers and integrators and customers thinking about this sort of option, on their projects. So as they're replacing systems, that they think about using a communicating power supply as opposed to what they've done in the past.
Absolutely. Great idea. Well, thanks to all of our listeners for joining us today on Control Intelligence, the podcast for Control Design Magazine. And thanks, of course, to Solar HD Emerson's Jay Hendricks for his insights into power supplies. Thanks, Jay.
Thank you, Mike, and it's great to be with you today.
If you enjoyed this episode of Control Intelligence, don't miss our older episodes and subscribe to find new podcasts in the future. You can find our podcast library at controldesign.com, or you can download all episodes via Apple Podcasts or Google Play.